Today we're going to look at multiplying fractions and putting the answer in its simplified form. So there's a few ways we're going to do that. We've got three particular that we're going to look at today. So let's get cracking. So let's start with this multiplication here. So probably the first thing that comes to mind, multiplication, multiply the numerators, multiply the denominators, and then simplify after we do that. So let's have a go at doing that. Now, you don't necessarily have to write out this step here, but I'm doing it just to be very clear with what I'm doing. 15 times 8, 10 times 8 is 80, 5 times 8 is 40, so 80 plus 40 is 120. So we've done our multiplication, now we need to do our simplification of this. So common factors of 24 and 120, I think 4 will go into both. So 4 times 6, 25, lots of 4 is 100, 5 lots of 4 is 20, so that's going to give us 30 all up. Now we got 6 on 30. Again, there's a common factor, 6. And we end up with 1 on 5. So what we've done is we've multiplied first and then we've simplified after. Perfectly valid. The strategy can get a little bit involved with the arithmetic if these numbers are big to start with. So here we've got 15 times 8, quite a difficult multiplication. We also end up, or can end up, with large numbers to simplify, which can be a bit difficult in terms of finding the highest common factor. So in my case, I didn't realize 4 times 6, I didn't realize that 24 went into 125 times. So I did it in an intermediate way, which can happen when you have big numbers. So an alternative strategy to doing this is to instead simplify the fractions first and then multiply them. So we'll do this with the same example. So looking at that first fraction, 6 on 15, common factor to both numerator and denominator is 3. So 3 goes into 6 2 times, and it goes into 15 5 times. What I haven't shown here is 3 times 2 is 6, 3 times 5 is 15. I've not shown that step, but you can show it if you like. 4 divided by 8, or 4 on 8. 4 is common, so 4 goes into 4 one time, goes into 8 2 times. So now we've got simplified fractions, we can then multiply. Now we can simplify, 2 is common to top and bottom, and we get our answer. So you can see this method was a bit different to the first. We had to simplify quite a few times, so we had to simplify all of those 3. However, the simplifications were far easier. Moreover, we didn't have to do massive multiplications, which was nice. It's probably a little bit easier doing this way in this particular example. However, you're not always going to be able to use this example because sometimes you don't have fractions that need simplifying first. Sometimes they're already in their simplified form, and then you would just use the top method where you multiply and then simplify after. Now there is a third method that I wanted to touch on, and it sort of comes up in this little bit of working here. It's a little bit hidden, so I'm going to expand out this little part to show you how we can make that a bit more efficient in how we do it. So up top we have a couple of different steps. We've got one step there, which is the multiplication, and then the second step is the simplification. So I'm going to sort of expand out those steps to show you what I mean. So this is going to be 2 times 1. Okay, so that's the end of the first step up the top. Then to simplify, we need to find a common factor. In this case, it's 2, so we write it as Okay, so we've written our common factor, cancel the top and the bottom, and we get 1 on 5. Now, what you can see from this is that there is sort of a double up in what we're doing. Here, when we're doing our multiplication, we get this, and when we're doing our simplification, we get the same thing. Now, when we've done it above, we haven't actually shown that, but that is what's going on in our head. So we're actually doubling what we're doing. And there's a simpler way to get through these processes. So instead of, and let me just erase out up here to make it a bit clearer. Instead of it, this first step, jumping from here to here, we can actually write it out like I've done below because it's going to save us some time, and I'll show you. So if we write this out instead, you can see that the top and the bottom both have a 2 in it. So we can simply cancel here and we end up with 1 on 5. And we don't have to show all of this working. We don't even have to do this multiplication step here because we've already got the simplified answer by cancelling there. Now, there is an even simpler way to do this. When we're doing this multiplication here, I know the numerators are going to come together at the top of the fraction, and the denominators are going to come together at the bottom of the fraction. So without even having to write that out, I know that these 2's are going to cancel just like they have up here. So I don't even need to show that. I can just show that I'm cancelling out the 2's, and I'm going to end up with 1 on 5. And you can see this process here ends up being a lot quicker than the process that we did above here. A lot fewer steps in it, and even here when we didn't show all of our working. So this is sort of cancelling in adjacent fractions when you're multiplying. Super quick. You just have to be able to identify that we have a common factor. In this case, the common factor of 2 and 2 is 2. So I'm going to show you a couple more examples to sort of dig into that a bit more. So again, if I multiply this, 5's cancel, we end up with 3 on 8. Don't even need to show this step. 5's cancel, we end up with 3 on 8. Perfect. One slight modification of this, if we had so in this case, I'm changing the 5 here to a 10. Again, if I multiply this out, and I'm going to write the 10 first, just to be a bit clear, we can see that the 5 and the 10 have a common factor, and it's 5. So just to be really clear with that. So that is my 5. That is my 10 in the brackets on the denominator. The 5's cancel. I end up with 1 times 3 is 3 on 2 times 8, which is 16. So you can see that the 10 turned into a 2 because 2 lots of 5 is 10. And the 5 turned into 1 because 1 lot of 5 is 5. So we don't even need to show all of this working here. What we can do at this stage is we can identify that the 5 and the 10 have a common factor of 5. 5 goes into 5 one time. 5 goes into 10 2 times. Then we have 1/8 times 3 on 2, which equals 3 on 16, which makes the process a lot quicker. Okay, this can be amplified where you don't only have 2 fractions, you have more fractions. So I'll show you a couple of examples with this. So now, right at the start of the video, the way that we would do this is we'd do 4 times 3 times 1 on the top. We would do 7 times 4 times 3, which is going to be a bit nasty. We'd do that on the bottom, and then we would simplify. But the first thing we can look at here are there common factors anywhere in the numerator and the denominator of these fractions? So here we have the 4s, cut them out, they're going to turn into 1s technically, because 4 times 1 is 4, 4 times 1 is 4, and you're cancelling the 2 4s. We've got 2 3s, they're going to cancel out, and we're going to replace those with 1s. So what we're left with in the numerator is 1 times 1 times 1, 1. 7 times 1 times 1, which is 7. And then we're done. So a lot simpler than multiplying the whole thing out and then simplifying. If we had a slight modification on this, then again the 3's cancel, and they're going to turn into 1s. The 4 and the 8, that has a 4 in common. So the one lot of 4 goes into 4, 2 lots of 4 goes into 8. Then when we're expanding this, in the numerator we have 1 times 1 times 1. In the denominator we have 7 times 2 times 1, which is 1 on 14. So again, you can do it when they're not exactly the same number, but when there's a common factor. Now, all of these examples that I've shown, the 3 has been adjacent to each other, or the thing that we've been cancelled is in the adjacent fraction. This doesn't necessarily need to be the case, so we could have something like this. So I'm swapping the first 2 fractions. Here the 3's cancel, it doesn't matter, they're not next to each other. The 4's cancel, and we're left with 1 on 7. Okay, so that's all the simplification that I wanted to go through. We had 3 different processes: multiply, then simplify, simplify, then multiply, or using our knowledge of common factors and just cancelling out in adjacent fractions. Now, there's one more thing that I quickly wanted to go through, which is going to help us later in the series, and that is multiplying a fraction with a whole number. So, a simple one. If we add a half times 2, we have 2 halves, we have a whole thing. Now, we can show this using fraction arithmetic. So this 2, we can write this as 2 divided by 1, and that's the key step that I wanted to show. 2 divided by 1 is just 2, but by writing it as a fraction, we can now multiply these things together using our fraction arithmetic. Now, there's a couple of ways to do this, as we've sort of done previously. You can multiply the top and the bottom and then simplify. So that's one way to do it. We could cancel, and then we're left out with 1, so that's another way to do it. So that's all I have for you. Hope you enjoyed. See you next time. This video forms a part of a worksheet series that aims to develop understanding of fraction arithmetic. So if you'd like to do the worksheets, visit the link in the description.